So, next question is just, I'm giving this graph, I'm not asking you to factor it or anything like this, and you're gonna run into one of these problems pretty early on in your homework assignment through Pearson. And I had a student come up to me and said they couldn't get it to factor, and they didn't read the directions. The directions said that you just wanted to discuss the end behavior here. So all we want to do is discuss the end behavior here. So end behavior, remember, deals with the leading coefficient and the degree of the polynomial. So what is the leading coefficient for this equation, which is 6x to the fourth minus 3x squared plus 2x minus 5? 6, which is positive or negative? Positive. All right, so we got a positive leading coefficient. We have an even degreed or odd degreed polynomial here. Even. So we have a positive coefficient on an even degreed polynomial. So what does that tell me about the end behavior of this graph here?
It's going to be up and down.
Start high and end high.
Yeah. Remember, if the leading coefficient of an even degree polynomial is positive, the graph starts high and ends high. So the end behavior starts high and ends high. All right, so we're good here. Now the next problems, we're actually going to go all the way through. Got 3 more to look at. We're going to go all the way through and sketch the graphs of each one of them. So the next one is f of x equals x cubed minus 4x squared plus 4x. All right, so that is my equation. So how do I go about factoring this equation? What's the first thing you do anytime you factor an equation?
You can take an x out.
Yeah, you look for, is there a common term with everything in here? And in this case, they all have an x in common. So f of x is going to be equal to x times x squared minus 4x plus 4, right? All right, so let's factor x squared minus 4x plus 4 out. What 2 things multiply to give you 4 that would add to give you negative 4?
Negative 2 and negative 2.
Yeah, negative 2 and negative 2. So we get x minus 2 times x minus 2. Well, let's rewrite this. How can I rewrite x times x minus 2 times x minus 2?
X minus 2 squared.
Yeah. So it's going to be x times x minus 2 squared. All right. So we know that this graph right here, I didn't talk about that. Odd degree polynomial, positive leading coefficient. So what are the end behaviors on this graph?
It's going to be start and low and end high.
Start low and end high. I'm going to put low to high. I don't know if that's... All right. So here we have x equals 0. What's the multiplicity here?
1.
1. All right, x minus 2.
2.
The multiplicity is 2. All right, so I'm going to start plotting points so that I can graph. Here's 0. Here's 2. All right, so we're going to start low. We're going to end high. This has an odd multiplicity, so what does the odd multiplicity tell us is going to happen here at 0? What does the odd multiplicity tell us? Yes, we're going to cross the x-axis at that point. So we start here, we cross the x-axis. All right, now, we got to get back to here. So we're going to turn to here, but what happens at 2? 2 has an even multiplicity, right? Because the exponent's 2. It's not because this is even, it's because the exponent's even. So this 2 is even, so we touch and turn away. So it's going to come down, kind of like that parabola did. It's going to come down, it's going to touch there, and then it's going to go back up. So the graph of f of x equals x cubed minus 4x squared plus 4x will look something like this. Now, for those of you who are going to go on further to take calculus, you'll actually learn how to come up with the coordinates of this point as well by doing a derivative. But that's, again, not something you're going to be tested on in college algebra, but just a little bit of looking ahead for those of you who do decide you want to be in an engineering field or something along those lines. A lot of medical fields recommend calculus. It used to be a local law firm that did not hire people who had not taken calculus because they wanted people who could think analytically. So the next question we're going to look at is one I'm going to go ahead and give it to you in factored form. It's -4 times x minus 3 to the third times x plus 2 quantity squared. All right, now, we know what the factors are in the multiplicity. Those are pretty easy to find. But how do we know about what the leading coefficient is in a situation like this where it's not written out? Well, one thing you could do is you could cube this term, and then you could square this term. And when you cube this term, that's going to have 4 terms. This will have 3 terms, so you'll have a polynomial with 7 terms. Anyway, it's going to get nasty. Now, I don't have a life, but I got better things to do than that. So, what I'm going to do here, I think I said that wrong. This has 4 terms and this has 3 terms. So it's 4 times 3, it's 12, and then you combine down. Oh well, anyway. It ends up, after you simplify it, it has 6 terms in it. So I was wrong earlier. All right, so anyway, let's get back to here. What you can do to figure out that leading coefficient is just think about the highest exponent associated with each parenthesis. That will give you the degree. So if I take this x term and cube it, that's the biggest it's going to get in here, so I'd have an x cubed term here. And here I have an x term and it's squared, so I would have an x squared term. And what is x cubed times x squared? X to the 5th. Now, what about that leading coefficient? Well, these would be a bunch of 1s, but then I have that -4 out there. So I would have a -4 with an x to the 5th in there. So what does this say about the end behavior of this graph? Starts high and ends low. Now there's actually a way to find the y-intercept here. Hines does not require me to teach this to you, but I will anyway. If you want to know the y-intercept, that's when x is equal to 0, right? So all you have to do is plug in 0 for x, and you would have negative 4 times negative 3 cubed. Negative 3 cubed is negative 27, right? So I have negative 4 times negative 27. That'd be positive 108. And then times 2 squared, which is 4. So 432 would be the y-intercept. That's going to be a pretty steep graph there, because it's going to go from being 0 at negative 2 all the way up to 432, and then it's going to go back down to being 0 again at positive 3. So this graph's going to be a pretty steep graph. But again, Hines does not require me to teach that, but it's still all right to see. All right, so what is my root associated with x minus 3? 3. Odd multiplicity. Again, not because this number here is 3, but because that exponent's 3. And then this would be negative 2. What's the multiplicity associated with 2?
You touch the x-axis and turn away.
Yeah, because it has what multiplicity?
Even.
Even, yeah. So it's an even multiplicity there. So cross and touch and turn.
There wouldn't be like a multiplicity of the negative 4.
No, because negative, you remember you get these roots by setting these numbers equal to 0, or these values equal to 0. Negative 4 would never equal to 0, so there's nothing to set equal to 0 there. Great question. Now, if there had been a negative 4x there, then you'd have negative 4x equal to 0, so x would equal to 0. So it would have a multiplicity of 1. Okay, so let's look at this. All right, so we go back 2 and across 3. And we start high, so we're going to start up here. All right, when we get to negative 2, we're going to touch and turn away, right? Now, if you remember, when we did this problem earlier, we said it had a really big y-intercept. So I'm going to come back to the graph right here, but I've got to go way up here. Anyway, and then I finally start coming back down. And then at this 3 value here. Now, this is free information for you. Street value on this is pretty high, but I'm giving it to you for free. If this exponent is just 1, it's going to cross straight through, clean, neat, everything. Now, it's still got an odd multiplicity, so it's still going to cross there, but because it's not a 1 as the exponent, it's a 3, it's going to do a little bending there. So it's going to cross here, but it's going to kind of bend and do something along the lines of that. I don't think you're going to have to worry about that as far as graph sketching is concerned in the homework, but it's just something to consider. Any other question there? Yes.
Why is it a negative 2? Like, why do you touch the negative 2?
All right. This had a root with negative 2, right?
Yeah.
Okay. So we got a root of negative 2 here, but we have an even multiplicity because the exponent is 2. So if we have an even multiplicity, the graph's going to touch and turn away at that point. So that's the reason it came down here to negative 2 and it did that bend to it. Any other question here? All right, great question. Again, if you want to with this stuff, you can go all different ways with this, and and the more stuff you work with, the more patterns that you see develop with it. So if you ever want to look even more into it, and other similar equations, like why did this have a positive exponent? Why didn't we cross here and touch and turn away here? And you start playing around with that equation and see what makes those different things happen in it. Like why is the y-intercept positive instead of negative, and so forth. And a lot of it's going to have to do with this leading coefficient. But anyway, there's so many things you can do as far as investigating and see patterns that I may not necessarily think to teach y'all in here. But there are a lot of neat things you can discover in these kind of graph problems. All right, the final example I'm going to give you is pretty much going to sum it all up. It's x cubed plus 3x squared minus 16x minus 48. All right, now, it's not a nice little neat trinomial that you can just factor out pretty neat, but there is a method that you learned, at least in Algebra 1. You may not have spent a lot of time on it in Algebra 1, but there's a method of factoring with 4 terms, and it's called factoring by grouping. And typically what I do in factoring by grouping, there will be 2 correct ways to set them up and 2 incorrect ways to set them up. I always just start off by grouping the first 2 terms together and the second 2 terms together. Or first pair of terms together and then the second pair of terms, I should say. All right, well, looking at the x cubed plus 3x squared, what's in common with both of those terms?
X.
Be careful.
What term?
The x cubed and the 3x squared. There's an x squared in common, isn't there?
Yeah.
Okay. So I've got an x squared in common, so let's pull an x squared out. And what do I get when I factor out the x squared?
X plus 3.
X plus 3. Is there a question about that? All right, now someone different. What about if I have the negative 16x with the negative 48? What would be in common with those terms?
-4. Actually, no, -16.
Negative 16, yeah. We'd have a negative 16 in common. If you factored out a -4, you would see that there would still be a common term in there, but negative 16 is correct. And we're left with x plus 3 again, which is very convenient for us. I told y'all I had a student earlier who ran into one of these problems, and she did the factoring like that, and she said, well, these 2 things aren't in common, so what can I do from there? And then that's when I looked at it for a second, then thought, oh, let me read the directions. And the directions just said discuss the end behavior, did not say anything about roots. So there isn't a guarantee. If it can be factored, there will be things in common. All right, so what happens with this? Well, I have an x plus 3 in common with this equation right here, right? So x plus 3 times x squared minus 16. And how does that factor? So difference of squares.
Do what?
X squared minus 16 is a difference of squares.
X plus 4, x minus 4.
X plus 4 and x minus 4. So here, everything here has a multiplicity of 1. Right. Oh, remember, this is a binomial. So both terms of this binomial had an x plus 3 in common, so that's what I pulled out.
Okay.
So that's where it is. They're both in there. It's just we don't normally see it like that. So each factor has an odd multiplicity. My roots would be x equals negative 3, x equals negative 4, and x equals positive 4. So I'm here. All right, back 3, back 4, and then to the right 4. Okay. So I've got my points there. All right, now, we didn't talk about this earlier. What are the end behaviors here for this problem? Odd multiplicity. No, not odd. I'm sorry. Odd degree, leading coefficient's positive, so it's going to start low and end high. So I'm going to start low. I'm going to come through across here. I need to bend right here. Now, my y-intercept here is negative 48, so it's going to go way down. Then it's going to come back up. It's going to go through like that. Again, next year, y'all know there's an art position open at the high school, so I probably won't be teaching calculus next year. I'll probably be teaching art. So y'all are fortunate or unfortunate that y'all had me this year. So that is the lesson, and I hope it was worth what y'all paid for the lesson today.